Good day everyone, so this is Sir Mar for your virtual instruction covering segments and sectors of a circle. Let us start off with your points to remember. A sector of a circle is a region bounded by two radii of the circle and their intercepted arc. So here we have the two radii, AC and BC, and the intercepted arc is arc AB. We will call this sector ACB. Okay? And then, we denote the radius as r and the measure of the arc as m. Thus, the area of the sector ACB is equal to pi times r squared times the quantity m degrees divided by 360 degrees. Next, we have the segment of a circle. A segment of a circle is the region bounded by an arc and the segment joining its endpoint. So here, you can see in the figure that the region bounded by an arc, which is AB, and its endpoints is the blue region, which is the segment of a circle. Now, how are we going to compute for the area of the segment? So this is how we are going to compute for the area of the segment. Area of the segment is equal to the area of a sector minus the area of the triangle. Okay? So ganun lang yung gagawin natin. Then we will be applying this one later with our activity 3. Before we move on with our activity, remember, if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency, just like in this figure. So this line here and the point tangency is at point B, and this C to B is a radius. Thus, it is perpendicular to the tangent line outside, and it is forming a 90-degree angle. For your activity 1 and 2 for week 5 to 6 lesson 1, please refer to virtual instruction week 5 to 6 lesson 2 as it is explained clearly in that virtual instruction. Let us now move on immediately for activity 3. So for activity 3, let me remind you to please include this in your activity sheet. The segment PT measures 10 square root of 3 centimeters and the measure of angle PAT is equal to 120 degrees. Now, let us have this example before you answer your activity. So in this given, we have circle H with HR is equal to HO is equal to RO is equal to 6 square root of 2 centimeters and the measurement of angle RHO is equal to 60 degrees. Now, answer the following questions. First, what is the circumference of the circle? Second, what is the length of arc RO? Third, what is the area of the circle? Fourth, what is the area of the sector RHO? And fifth, we have to solve for the area of segment RO. So let us first establish the given in our figure. So as given, the measure of the sides of the triangle is equal to 6 square root of 2 centimeters. And the measure of angle RHO is equal to 60 degrees. And since this is a central angle, we have the arc RO, which is equal to 60 degrees. Now we can solve for the circumference of a circle with the use of this formula. The circumference is equal to 2 pi r, wherein r is your radius and c is the circumference. And pi, we will approximate it as 3.14. And your r is already given, which is 6 square root of 2. By substitution, we will have the approximation of the circumference, which is equal to 2 times 3.14 times 6 square root of 2, and this is approximately equal to 37.68 square root of 2 or 53.29 centimeters with the use of a calculator. Now, to compute for the length of arc RO, we are going to use this formula wherein we will be multiplying the circumference, which we have computed earlier, by the fraction of the degree measure of arc RO in comparison to the whole circle. So we will have to substitute the equivalent or the approximation of our circumference, which is 37.68 square root of 2, and multiply it by 60 degrees divided by 360 degrees. And by computation, we will have 6.28 square root of 2 or 8.88 centimeters. Now, to compute for number 3, which is the area of the circle, I just have to remind you that this is the formula for computing the area of a circle, which is A is equal to pi r squared, where r is your radius. So by substitution, we will have 3.14 times 6 square root of 2 squared, and this is approximately equal to 226.08 centimeters squared. Now, let us move on with the area of the sector RHO, since we know that sector RHO is just a part of the whole circle, and we already know the area of the circle, wherein we will be using that area of the circle to compute for the area of this sector. And as you can see in this formula, pi r squared, and this is just the same as the formula for area of the circle. So by computation, we already know the values we need. So we will have 3.14 times 6 square root of 2 squared times 60 degrees divided by 360 degrees. And by computation, we will have this approximately equal to 37.68 centimeters squared. Lastly, for item number 5, we are going to solve for the area of segment RO. So the area of segment is equal to subtracting the area of the triangle from the area of the sector. And since we already know the area of the sector, we need to know what is the area of the triangle here, RHO. So we can do this through Pythagorean theorem or the formula for computing the area of equilateral triangle, since this is an equilateral triangle. But then, if we are going to use Pythagorean theorem, this applies to all kinds of triangle. Kaya, hindi tayo mag-worry kapag hindi man siya equilateral. Okay, so we will have this first through Pythagorean theorem. So by Pythagorean theorem, we have a squared plus b squared is equal to c squared, wherein c is our hypotenuse and a and b are the legs of a right triangle. So we are going to form a right triangle in this triangle RHO by drawing a line wherein it divides segment RO or side RO into two equal parts, wherein it will measure 3 square root of 2. So we'll now have the right triangle here. And by having it named through the Pythagorean theorem, we will have A, the altitude, and then B as the base, and C as the hypotenuse. And by substitution, we will have A squared plus 3 square root of 2 squared is equal to 6 square root of 2 squared. And by computation, we will have A squared plus 18 is equal to 72. And we subtract both sides with 18. So we will have 72 minus 18, and that is just 54. And the square root of 54 is equal to 3 square root of 6, or approximately 7.35 centimeters. Now that we already know the altitude and the base, we can now compute for the area of the triangle, and we will have 1/2 times base times the height. We will have 6 square root of 2 times 7.35 divided by 2, which is approximately 31.18 centimeters squared. Now let us have the other method on how we can compute for the area if it is an equilateral triangle. So let us have S represent the measure of the side. So we have the area is equal to the square root of 3 over 4 times S squared. So by substitution, we already know that S is equal to 6 square root of 2. So we will have square root of 3 over 4 times 6 square root of 2 squared. And this is approximately 31.18 centimeters squared. Now that we already know the area of the triangle, we can now go back to the area of the segment RO. So to compute for the area of segment RO, we are now going to subtract the area of the triangle from the area of the sector we have computed earlier. So we have 37.68 minus 31.18, and the area of segment RO is equal to 6.5 centimeters squared. So that would be all for our virtual instruction covering sectors and segments of a circle. Thank you and stay tuned for the next virtual instruction.